Dear student, today we will study about Kirchhoff laws. Kirchhoff laws are very useful for doing analysis of electrical circuit. First of all, we should understand what is the meaning of analysis of the electrical circuit. See, here we are having very simple electrical circuit. Okay, so what we are having in this, we are having these two sources and three resistors. A simple electrical circuit. So analysis of this electrical circuit means we are finding whatever the current flowing through these resistors or what is the voltage across this resistor. So finding current flowing through it or maybe finding voltage across each resistor, that is called as analysis of electrical circuit. Or anywhere, any point, somewhere here it is asked find the voltage, okay, or somewhere find the current through this branch. So this is simply analysis of the electrical circuit. So these Kirchhoff laws are very useful for doing analysis of electrical circuit. Now Kirchhoff has given two laws, okay, first law and second law. So here first we'll go for the first law. So first law, this is the name having. Now one more name is that is junction law. One more name is given as Kirchhoff current law. So first law is having two more names. Okay, so now before going to the statement of this law, we'll go for one simple term. Okay, what is that simple term? That term is a node, or maybe it is called as junction point. So what is this node or junction point? See, in electrical circuit, okay, the point where more than two branches are meeting, that point is called as junction point or the node point. Okay, it's a meeting point of more than two branches of electrical circuit. Meeting point of, okay, more than two branches of electrical circuit. If you just see this one, this is one branch, this is other branch, this is one more branch. So these three branches are meeting at this point. So this is a node or junction point. Similarly, you can see this point also. So here also one branch, two branch and three branch. So here again more than two branches. So it is also called as a junction point or node. So I think it's clear. So why we are studying this term? Because whatever this first law is applied on node or junction point of the electrical circuit. So we should be clear what is this node or junction point. Now we'll go for the statement. It's very simple. Okay, algebraic sum of all the currents, algebraic sum of all the currents to a node is equal to 0. To a node is equal to 0. Very simple statement. Okay, so here for simplicity, okay, let whatever this branch and this branch, I'll draw in this way. Okay, it is easy to understand. Let this current is I1, okay, from this branch. Let at this branch current flowing through this I2 and through this branch current is I3. So simple way I have drawn this one. Now what this statement is saying, what is this law? Algebraic sum of all the currents to a node is equal to 0. So here I can write, I'll use this summation symbol, algebraic sum. Okay, all this current, so I use this current is equal to 0. But what is the condition? Which current? Okay, sum of which current? Whichever coming to this node, whichever related to this node. Either coming or going, okay, but related to this node. So condition is node. Okay, so according to this statement, I'll write that one. Okay, what we are having? Current I1 is there, I2 is there, and I3 is there. So if directly I am doing the sum and I am writing that sum of all this current is 0, so this statement, okay, mathematical equation will be wrong. Okay, will be wrong because we didn't use the proper sign convention. What is this sign convention? See, here you can find the current having according to node two direction. Okay, one direction is towards the node and other direction is away from the node. So coming towards the node and away from the node, these are two opposite direction. So we can't consider as same. Both the currents we are writing positively. That's wrong. Simple example I'll give you, like this debit and credit. Okay, when amount is credit, it is added. Amount is debited means it is subtracted. Okay, so these two are opposite operation. So similarly here also, okay, coming towards the node and away from the node, these are having opposite direction. So let here sign convention, towards the node you will consider positive, towards the node. So take this as the positive direction and away from the node, away from the node. So this you can consider as negative direction. Okay, so if accordingly I'll write, so I1 will be having the positive direction because it is coming towards the node, and I2 or I3 are away from the node. So we can use that it is negative. I3 is also negative. So simply you will get I1 minus I2 minus I3. So this is the correct one. Now using this one I can write, okay, I1 is equal to I2 plus I3. So one more equation, easy equation to remember this law. What is this side? We are having, okay, current coming towards the node. Here we can say it is incoming, and coming moving away from the node, that will call as outgoing current. So here we can say simple way, algebraic sum of incoming current is equal to algebraic sum of outgoing current. Here only one current, that's why we are written one. But here we are having more than one, so we have done that one. So algebraic sum of incoming current is equal to algebraic sum of outgoing current. So in this way also we can say that the Kirchhoff's first law. So here in a simple way I have explained what is this, okay, the first law of Kirchhoff. Okay, hope you understood this one. Okay, thank you, all the best.